Assalamu alaikum viewers. So today we are going to solve Feb March 18 paper 1-2 AS Physics question 6. Oh, this is an oscilloscope. So you must be confused about oscilloscope because many students find difficulty in solving this. I have a really easy formula for you to solve. When I was in my O levels, it was also very difficult for me to solve oscilloscope questions. I used to skip them usually. So let's see. Question 6. A cathode ray oscilloscope is connected to the alternating voltage. The following trace is produced on the screen. As you can see the trace. The oscilloscope time-based setting. Okay, always remember the time-based setting is on the x-axis. Okay, time-based setting gives you the value on the x-axis and y-plate sensitivity gives you the setting on the y-axis. Okay, so on cathode ray oscilloscope, you could find the time period from the x-axis, and from the time period, you could calculate the frequency of from the x-axis, of course, and from y-axis by using the y-plate sensitivity, you could calculate the amplitude of the trace. Okay, so now let's see the options. Which statement about the alternating voltage is correct? As I told you before, that you can calculate the time period, frequency, and the amplitude, but you cannot never ever calculate the wavelength. Wavelength of the oscilloscope trace cannot be known by this oscilloscope at AS level especially. I don't know about further, but at AS level, you cannot find a wavelength, and it's not even in your syllabus to calculate the wavelength from the cathode ray oscilloscope diagram. Okay, trace I mean. So this option is wrong. Now let's check on the other options. Amplitude. Let's look at option A. It says amplitude. Amplitude is 3.5 centimeters. You must be thinking I would count. And what is amplitude? Amplitude is the distance from the mean position to the maximum. It is actually the maximum displacement from the mean position, right? So how would you find the mean position? Is actually in this it's very easy. You have to look from where the trace starts. So the trace starts from here. So this would become this line. I will draw it for you. This line becomes your mean position. Okay. So from here you would count how many blocks are covered by this trace to reach its maximum position. 1, 2, 3, 3.5. You must be thinking that option is correct. No, as I told you before, you have to use the Y gain sensitivity reading given to you to calculate the amplitude in oscilloscope trace. So this option is definitely wrong. If you want me to solve it, like I would tell you the amplitude it would be actually 3.5, the scale reading multiplied by the reading given to you. So 3.5 multiplied by 2 would be give you 7. So 7 would be the 7 volts would be the amplitude of this trace. Now option B and option C, they both would be found from one thing. Like for example, if you are able to work out the time period, then frequency would be definitely known to you. So now let's look at the working, which I have already done for you. Okay, so this is the working which I have done for you. Now first of all, see, the time-based setting is given in millisecond. Remember, always in physics, you have to give the quantity, and if you find especially from another quantity from the one quantity, then you must convert the unit to its base unit. So the base unit of time is seconds, not milliseconds. So first of all, the first thing you have to do is to convert this time-based setting from millisecond to seconds. So you have to divide by 1000 and you got this time-based setting in seconds. Multiply. Now the easy way to solve the oscilloscope question is just, now what is time period? Time period is actually the distance, the time in which this is the time taken by one wave to travel from one position to another, right? So now we will check that how much time, how many blocks actually. You have to count the blocks that are taken by one wave. So this is one wave. Okay. So 1, 2, 3, 4. So it takes 4 blocks. So 4 blocks are covered by one wave. So we will multiply the scale reading, which is this, which you found at 4, by the number by the reading given to you, which is time-based setting. So time-based setting multiplied by 4 would give you 2 into 10 power minus 3. This is your time period. So how would you find a time period? You will simply multiply the time-based setting by the number of blocks covered by one wave to find a time period. So your time period is 2 into 10 power minus 3 seconds. Now, as you can see in your option is given in milliseconds, so it's very easy. You have to multiply it by 1000 and then you would get 2. And in the option, it says that the time period is 1 millisecond. No, it's wrong. It's 2. So option C is also wrong. Now, it's very clear that option B is the correct answer, but let's do the solution. So now to find the frequency, you have to reciprocal actually the time period. So you did the reciprocal and you found 500 hertz. And an option is given to you in kilohertz. So you would divide it by 1000, of course, and you would get 0.5 kilohertz. So option B is the correct answer. Thank you so much, viewers, for watching. If you have any question, you may ask in the comment section below. And please like, subscribe.